Hi there, kids. Time for another math lesson from Module 2. And this is for Lesson 16, where we are using mental strategies for multi-digit whole number division. And we're going to be looking for patterns. We're going to use divide by 10 patterns, maybe divide by 100 or divide by 1,000, but it's really by this 10, we're going to look for the zeros. And then in lessons 17 and 18, we are going to continue kind of this big idea of dividing, and it's going to help us eventually get to the standard algorithm and dividing with whole numbers, decimals, and you name it, you can divide it. So important words here, you should really make note of these words in your notebook. The dividend is inside the bracket. The dividend is what is being shared. If you write it with the bracket, then the divisor is on the outside, and the quotient is the answer on top. We've gone over this before, but really important words to know. When you write it out like this, the dividend comes first. Again, this is the whole that's being divided. The divisor comes next, and the quotient is the answer. So important words in division, you might see things like shared, equally used, distributed equally. Those will be really important words. And the pattern today is going to be taking something like looking for basic facts, like 36 divided by 9 equals 4, except they're going to have 360 divided by 9. And so then they'll be tossing these zeros around with the 360 or perhaps 90, the 3600 divided by 90. And so you want to pay attention to what's happening with the zeros. So they have this little pattern thing that you can do. You can take each place value position apart, create disks, to then show how they're being shared by the divisor. The divisor is in the middle. So if you make 4 hundreds and then 20, so each piece is going to get divided by the 10. So 100 divided by 10 is 10. And again for 10, and again for 10, and again for 10. But 10 divided by 10 is 1. And when you add up all these pieces on the right side, that's where you're getting your answer. So that's what that is all about. Kind of an interesting looking method. And then a few other examples where you can kind of make note. This is where we're going to start getting into the old way or the shortcut that your parents are going to love because it actually is really handy. But it's because of that dividing with the 10 pattern that you can use the shortcut. So we're really going to be using the shortcut a lot. Basically, I'm going to use the word match or find a pair of zeros, and when they match, you can take off. If I've got 2 here and 2 here, then they're going to offset. Why? Because you can divide by 100 on each side and sort of reduce the size of your numbers here to help you have a simpler problem here to help you find your answer easily. Same thing with like the word 100. It's just a label, okay? Just like this is 1600 divided by 100. 16 divided by 1 is 16. And so then if you have non-matching zeros, okay, I have 3 here and only 2 here, you can only offset the ones that will have this equal divisor. So if I have 100 that will go evenly into this and this, then just use the 100. Don't worry about this. Leave that as part of your dividend and then proceed with your division. Many, many zeros in today's lesson. You can also divide by 1,000 to simplify your problem and get an easy quotient. So I hope those notes are helpful. Remember to always pause, go back, take your time, get the video notes. Okay, so our directions here are to divide. Draw place value discs to show your thinking for at least A and C. You may draw discs on your personal whiteboard or in your book, like why would you put it on a board and then it gets erased? To solve the others if necessary. I'm not a big fan of the whiteboards, only in class when you guys are showing me answers because it's a great communication tool. So let's take apart this 500 and divide by 10. So if I have 5 100s, that's kind of small, but 1, 2, 3, 4, 5, then I would make each disc 100. And then I would divide by 10 so that each time I have 100 divided by 10, that would give me sort of an easy answer. and then this one for this one, and 100 divided by 10, 10 more, and 10 more, and 10 more. So you'd get 10, 20, 30, 40, 50. And that would be your final answer. Now, the shortcut way that I'm going to show you is to take each number, look for as many zeros as you can match on either side, and this is one for each. Okay, that's going to be that 10. So if I divide 500 by 10, I get 50. And if I divide 10 by 10, I get 1, which really makes my problem 50 divided by 1, which is 50. This is the old way, the classic way, and this is the new way. These are the discs that they're asking you to show for A and C, and then this is the way that we're going to kind of move into. Okay, so if you have 360 divided by 10, you don't have to do the discs here if you don't want to. If you had something with 2 place value positions, you would make discs for each place value position. There's your 300, but now you need 6 tens. 1, 2, 3, 4, 5, 6. That's why I don't like to do them all the time, because it takes a lot of time. But this is what your 360 would look like. Then all of that is going to be divided by 10, and you have lots of shifting. So 100 divided by 10, there's 10, another 10, another 10. That's for those 3. Check, check, check. And then 10 divided by 10 right here, we're going to have 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And so that is going to be your final answer. 36, not 31, 36 as your final answer. Okay, 36. Okay, now if I was doing this the old way, I would take my 360 divided by 10 and say, look, a pair of matching zeros. Slash each one off to give me 36 divided by 1, and I get 36 as my answer. So one more set of place value discs, and then we'll get into the easy way. So 12,000, again, this is going to be with a couple of rows of tens and hundreds, thousands. This is a 1 in the 10,000s. So we'll just give one place value disc for the 10,000. And then we'll have 2,000s here. Now you can divide by 100 for each of these, which is going to give you your 100, because if it was slash, 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 that leaves you with 100 left. And then for this 1,000 divided by 100, hop, 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 hop. And so then you should end up with 120 and slash, 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 slash 120 divided by 1 equals 120. Sorry. There you go. Okay, so now that hopefully you understand what's happening with all of these place value discs, let's just move into the finding the matching zeros and rewrite the problem that we have left. So if I have a pair of zeros here, 2, then I have 2 here. I can divide both sides by 100 and end up with 4,500 divided by 1 for 4,500. Okay? And then how about at the bottom here? How many zeros do I have that match here? Well, I have 3 here and 3 here. So that would leave me with 700 divided by 1 for 700. You see how easy it is once you get going? You can spend the time with the place value discs, but it almost confuses everything. So what you're doing, remember, is you want to divide by the maximum number of 10 or the maximum multiple of 10 before going over. I only have 2 zeros here, so I can only take off 2 zeros here, which leaves 5,300 divided by 1 for 5,300. Okay? Easy peasy. Don't you like the old way? I like the old way on pretty much everything. But tape diagrams really are helpful. Okay, so now we're going to divide, and we're going to do it in steps. And this time, instead of having always a 10 as a divisor, 10, 100, or 1,000, we have a number that is actually going to be compatible. So it should be an easy fact. And we're going to remove what we can before we divide by this other number, okay? So kind of like in the notes I was showing you how to do it. So let's just copy and model what they have. So if I have 12,000 divided by 300 instead of 30, so pay attention to what they're doing. They're keeping the same dividend, but they've changed the divisor. So I've got 12,000. But instead of dividing by 10, because I only had one zero there, I'm going to divide by 100 because I have two zeros. I want to take off the two zeros. Then I want to divide by the 3. So I have to eventually include that. You can't forget about it. That's part of your divisor. Here's where you can simplify. 2 zeros off, 2 zeros off. That will become 120 divided by 3. Okay. Now I'm really just dividing 12 by 3 to get 4, and that 0 comes down. So I end up with 40. Okay? Making sense of that? Here we have 12,000 again, but I have 3,000. So I can take off 1,000 or 3 zeros before I divide by 3. Work this one out. If I take the 3 zeros here and 3 zeros here, that leaves me with 12 divided by 3, which gives me 4. Okay? So it's a pattern of going across. Let's do another one. 560,000 divided by 70 will only allow me to take out 10 before I divide by 7. Here's the 0, here's the 7. I can take off 1 0 for these, which leaves me with all this. 5, 6, 0, 0, 0. Put your comma in. Then divide by the 7. Now, this is your basic fact. 7 divided by 56 is 8, but all these zeros have to be accounted for. 1, 2, 3. So I have 8,000. And that makes sense. When I have a big number divided by a not so big number, I should have a pretty big answer. But these divisors are getting bigger and bigger. That's why the answers are getting smaller and smaller. Same dividend, 560,000. But divided by 700 means I can take out 2 zeros before dividing by 7. If you remove those two as they match, you get 5600 divided by 7. This is the 8. Then you have your 0, 0. Do it again. Okay, I know I'm sorry if I'm going too fast, but it's really just a pattern. So take your 560,000. Look for how many you can take out. Let's take out 1,000 or 3 zeros. Then divide by 7. 3 zeros out, 3 zeros out leaves you with 560 divided by 7. This is 8, and then this comes down. How do you like that? How do you like them apples? All right, let's do the last one here. 28,000 divided by 40. So I can take out all of 1 0. So 28,000 divided by only the 1 0, 10, and then the 4. Remember, we still have to divide by this number or digit. Okay, so now we can take off this 1 0, leaving us with 2,800 divided by 4. 28 divided by 4 is 7, and you end up with 700. Do another one. This is different now. Okay, they had the same dividend, but just different divisors. Now we have a little bit of a different dividend, but that's okay. We're ready for it. So I have, how many zeros can I take out? Copy, and then take out as many as you can. It's going to be 100, and then divide by 5. Take off these 2 zeros, rewrite your dividend. 4,500, divide by 5. This divided by this is 9, and the 2 zeros come down. Okay. And the last one, how many zeros can you take out? They both have 3 extra. Remember, you make a match. 1, 2, 3, 1, 2, 3. So it's 810,000. Then divide by 1,000 before you divide by 9. You can take off 3 here, which leaves you with 810 divided by 9. 81 divided by 9 is 9, and this other 0 comes down. It's just looking for the pattern and identifying what they are. So moving right along into the word problems now. The floor, when we have 2 pages of word problems. Sorry about that. I didn't do it. I'm just trying to help you. The floor of a rectangular banquet hall, rectangular, big, important part, has an area of 3,600 meters squared. The length is 90 meters. What is the width? So one thing you have to know, they're going to throw this at you all the time, is area equals length times width. If they give you certain dimensions, what you have to do is you have to plug them in. Plug them in. My teachers would say, plug them in. And I'm like, what do you mean? Well, just fill it in the blank where it belongs. So if this is where the area belongs, and they're telling you that the area is 3,600, then put 3,600 meters squared for the area. Substitute it in. The length is 90. Substitute that in. What is the width? Don't know. Okay, so what you're doing is you're creating something you can work with. Now, when I have an equation that has part of the number here, part of the number here, and something missing, then what you can try to do is to, well, there's so many algebraic things. It's like, oh, move this over from one side to the next. But what we want to do is we want to be able to take the 3,600, divide it by 90, so that we can figure out how many parts to create our square. Couple different ways to do this. We'll take our 3,600, divide by 90, just keeping things simple. This is all meters. We have our offsetting by 10. There's only 1 0 on each one, and then by 9, okay? That takes off those two, leaving you with 360 divided by 9. That's 36 divided by 9 for 4, and the 0 comes down. And the lights go out in the city, and we turn it back on. And so the width is 40 meters, and you can prove it by doing 90 times 40. That, of course, is 36, and then you've got this 0 and this 0. And so you can prove it. Anyway, I could spend a lot more time on that one, just kind of having some fun with algebra. We'll move on. There's part B, a square banquet hall, has the same area. Now, for this one, they literally give you no information. They just tell you that it has the same area. We know the area, 3,600 meters squared, but we don't know the length and we don't know the width. But one thing we know about a square is that all the sides are the same length. So whatever this side length is, this one has to be the same. Same here and same here. That means this has to be the same as this. So what 2 numbers can you multiply to basically get that? Okay, because this can be on one of them and this can be on the other. So you have to just think about, this is kind of a trial and error problem, but what numbers can you multiply to get 36? And students will say, oh, 9 and 4, and 12 and 3. And I'm like, no, it has to be the same. So a digit times a digit equals what? And so then they come up with 6, which is great because 6 times 6 gives you the 36. But I need 3,600. So if you take the 6 and you put 1 0 on each one, then you can have your 60 times 60. So the length is 60 meters because it has to have the same. Okay? And then this one, we should also write the width is 40 meters on the rectangular banquet hall. Now the third banquet hall is rectangular, and it has a perimeter of 3,600 meters. Perimeter this time, same number, but it's the perimeter. Now that's the distance around. Okay, so if I have a rectangular banquet hall, let's just say it's that, and the perimeter going around is 3,600. If the width, what is the width if the length is 5 times the width? Okay, so it's actually, my model should be a little bit shorter. Okay, because if the length is 5 times the width, then the width would be like this, but the length would be 5 of them. Okay, so if you take that, and that is 1/2 of your figure, because remember that's just the short and the long, but you have to get all the way around it, then I would also have another width and another length. So that's a lot of pieces to create the whole. In fact, how many pieces is that to divide it into all those equal pieces? Remember how the tape diagrams, I said these are so helpful? So this is actually 5 plus 5 is 10 plus 2 more is 12. This is 12 units. So if you want to know how to solve for this, look at what the total is. Okay, and the total is 3,600 meters all around, but it's in 12 pieces, which looks a lot like 3,600 divided by 12. And I don't have any zeros here, but that's okay. I can divide 36 by 12 and get 3, and then the zeros come down to show you that we have our 300. That's for one piece, which is the width, meters. Okay, width, W-I-D-T-H. I can spell. There I can. Yippers. Okay, so 300 meters is the width. And more. Don't leave yet. Don't leave. Click subscribe, in fact. Come back again. Watch me try to focus my camera. There it is. Try again. Ha! Thank you. A win. All right, almost done. 2 fifth graders solved 400,000 divided by 800. Carter said the answer is 500, while Kim said the answer is 5,000. Who has the correct answer? Why don't we just do it and see? So if 2 fifth graders solved this, 400,000 divided by 800. Let's do it correctly. Let's see what happens. If I could divide each side by 100, then that would save me, okay, I would have 4,000 divided by 8. It would save me a little bit of work. Now, when I do this problem here, watch out, because I'm not dividing 4 by 8. I'm dividing 40 by 8. That gives me 5 with 2 extra zeros. Okay, so you have to explain what you're thinking here. And so we're going to say that Carter is correct because the basic fact is 40 divided by 8 equals 5. There are 2 extra zeros. Okay, and this is after dividing both sides by 100. Okay, so basically if you divide both sides by 100, you end up with 4,000. Oops, I already wrote that. 4,000. You can do the whole other thing if you want. 400,000 divided by 100 divided by 8. Squeeze that in there to give you your 4,000 divided by 8. Remember, this is the old way, super fast. New way, a little bit more work. But you get your 500, and so Carter is correct. And then you have your thinking right here. This is very important. Always make sure to write your explanation. Now, what if the problem is 4 million divided by 8,000? What's the quotient? Well, we can try that. Write out all your zeros. Okay, and what's the quotient? Well, you can just do the whole thing again, divided by 1,000 this time because I have 3 here and 3 here. Then you can divide by 8. But that's going to take off 1, 2, 3, 1, 2, 3, make a match. That leaves you with 4,000 again, divided by 8 again. Okay, so we're going to end up with the same thing, 500, again, because we divided by a bigger number. They increased the size of both the dividend and the divisor by an equal amount, and then it gives us the same quotient. So anyway, I hope this is helpful. Come back again, watch another video, click subscribe. We'll see you on another one. Bye.